Welcome back, Mustangs. So we're actually going to go ahead and do our second example using the elimination method for solving systems of equations. In our first example, once we identified that both of our equations were in standard form, the first thing we did is we looked at each of the terms and we looked at their coefficients to see if they were equal coefficients or opposites. In our first example, one of them was. So here in our y's, they both had the same coefficient, which was great. But what happens if when we're looking at those terms, like in this example that we're going to do right here, if the coefficients are not equal or they are not opposites? So we're going to learn how to go ahead and solve this system today using, again, the elimination method. So in this example, if you notice, if we look at our x terms, our coefficient right here is a 1, and right here our coefficient is a 5. So 1 and 5 are not equal, and they are not opposite. And then over here, if we look at our y terms, this one has a coefficient of a positive 2, and this one has a coefficient of a negative 3. So again, a positive 2 and a negative 3 are not equal or opposite. So what we have to do, even though we don't have equal or opposite terms, is we still need to create a 0 somewhere. We still either need these terms to turn into a 0 or we need these terms to turn into a 0. So what we're going to have to do is we're actually going to have to multiply either one or both equations by a constant to try and get those terms to cancel out. So we can actually do this problem two different ways. The first way is if we wanted to cancel out our y terms, basically what we can do is we could multiply this entire bottom equation by a positive 2. And then once we distribute that 2 all the way out, basically what would happen is down here we would get a negative 6y. And then we can multiply this entire top equation by actually a positive 3. And then what would happen is when we distribute it, we'd get a positive 6y, and then a 6y minus a 6y would give us a 0. But just saying that out loud, that sounds really complicated and like a lot of math. So let's see if there's an easier way. So there actually is going to be an easier way, and that is if we go ahead and get our x's to cancel out. So here again we have 5 x's, and here we have an x. So I'm wondering if there's anything we can multiply this equation by, specifically this x by, to get a term that would cancel out or turn a 5x into a 0. Well, if we were solving a regular equation and we were trying to get rid of 5x's because they were positive, we would just do the opposite. We would basically subtract 5x's. So what would we need to multiply this x by in order to turn this into a negative 5x? Yeah, we need to multiply this entire equation by negative 5. So that will actually be our first step. We're going to multiply the entire top equation by negative 5. And when we do that, that means we're going to be using the distributive property. And when we distribute, it means we are multiplying the negative 5 by every term or every bubble inside of these parentheses. So when we do this, a negative 5 times x gives us negative 5x. Negative 5 times a positive 2y gives us negative 10y equals. And a negative 5 times a negative 2 gives us positive 10. So now what we can do is now if we go ahead and add these two equations together, I think you'll find we have a term that will cancel. So 5x's minus 5x's gives you 0. If you have 3 negative y's and you have 10 more negative y's, you have a total of 13 negative y's. And then a 29 and a 10 gives you 39. So again, the whole purpose of the elimination method is to eliminate either your y's or your x's so that you get one equation with only one variable that you can solve for. So how you eliminate one of those sets of variables is by figuring out how you need to make a zero pair. So if you want to get rid of your x's, what does your other x term have to be in order to do that? So in this case, in order to get these 5x's to turn into a 0, we needed this to turn into a negative 5x, and the way to do that would be to multiply it by a negative 5. And you can't just multiply one term, you have to multiply everything by that number. So again, when we did that, we got negative 13y equals 39, and now we have an equation with only one variable that we could solve for. So we have one last step to get y by itself, and that's going to be divide each side by a negative 13, so we're getting a coefficient of 1. When we do that, 39 divided by a negative 13 is actually going to give us negative 3. So again, what we found, and please be careful, what we found is actually our y value this time. So our y value, again, in our ordered pair is going to come second. So our y value is going to be negative 3. And so now what we're going to do to figure out our x value, so we're going to take this y value and we're going to plug it back into one of the original equations. So again, it doesn't matter which one you pick. I think the first one looks a little bit easier, so I'm just going to pick the first one. So I'm going to rewrite this, but again, once I get to the y, I'm going to stop. I'll put parentheses, and inside the parentheses, I'm going to put the negative 3. So this equation starts with the x plus 2. I see a y, so I stop. Instead, I put parentheses because y is actually negative 3. So I put the negative 3 inside the parentheses equals negative 2. And again, I just do the math I see. So this is 2 times negative 3, which is negative 6. To get x by itself, I need to create a 0 pair, which means I need to do the opposite. So I'm going to add 6 to both sides. So x, negative 2 plus 6 is going to be 4. So my x value, when these two lines cross, is going to be at 4. My y value is going to be at negative 3. And that is how you solve systems of equations by elimination when you do not have the same or opposite terms.